So this is 2018 higher level. So it's A1, so it's the first part of the short questions. We're going to do it in the papers today. I prefer to have the papers that you can pull out. We don't have them printed. So it's page 18 for this year's 6 years. So 2018 higher level anyways if you don't have the exact same papers, and it's A1. Okay, so it's axonometric. So again, we have two views here. We have our front view, we're assuming this is, or you could call it the end view, depends which way you're looking at, and this view or front view, and we're going to project them in. So we're given a few bits that have been completed for us. So basically we have this structure here, we probably have a similar structure here, and we have one piece of the bike rack by the looks of it. So it's just coincidental when this comes through that it hits both of those points. So what I'm going to do is I'm going to construct the outer structure first. So in order for me to do it, I'm going to label the points. So I'm going to call this point 1, 2. So I probably should start here. 1, 2, 3, and 4. And that was 1, 2, 3, and 4. And that would make sense that then 1 was here, 2 was the top one, 3 was the one at the back, and 4 was at the bottom. And the reason I labelled that to see what I had first was just basically so that I can do the opposite side. So I'm going to start the same thing. So I'm going to call it 5, 6, 7, and 8. And that will be 5, 6, 7, and 8. So apologies about the thickness of the markers, but basically I have this sort of structure here on both sides. So actually, because this is zoomed in, I might use my pens, which are just here rather than the markers, which can get a little bit confusing. So they used a red, so I'll try a pink and see how it works out. Now I'm going to use sliding set squares to do this. If this was in the actual day of the exam, you could stick on this page. This is a fold out A3 page, which you get in the day of the exam. But because we're using the papers, we'll just sort of have to balance it a little bit. So actually, for this, they've already brought down the lines. Okay, the only thing I need to actually do is extend them on a little bit. So I need to extend on 3. That one looks long enough. I think maybe it needs to be a little bit longer actually. We'll see for the 6th part. This one here needs to be extended on. So again, if you were using this to be stuck onto the page, it'll be a little bit more accurate. So what I need to do now is I need to bring down these ones at the same angle as this. So I'm going to use my sliding set square method as best I can. So it's not perfect using adjustable set squares. It's a bit difficult, but we just have to make the best of what we can. So there's 6. There's 7 being brought down. There's 5 and there's 8. Okay, so we'll follow them around. So 5 has intersected here. So there's 5. And maybe we'll use a thinner marker to mark that. So I maybe use a black pen or something just to mark. That's not black. To mark the crosshairs. Okay, so there's 5 and 8 is at the back. So that looks to be 8. Okay, 7 comes down here and 7 comes from this one, so there's 7. Okay, so it seems to crisscross onto the other view. And 6 comes down here and there's 6. Okay, bit unusual that it crisscrosses, but that seems to be the way they've made it. It has happened before. Okay, so again, in an exam, the best thing is to assume that you're correct and continue on. So I'm just hoping I can't see any mistake I've made except for possibly a small bit of inaccuracy. So I think I'm happy with that. Okay, so we have these bars then along the top. So I know I have that one and I know I have that one. I can sort of see them here. Now I have a middle one shown here, and you suppose the question said, well, is it here? And it's not shown on this drawing because it would just be a thin piece, but it is shown here. So what will I do? Basically, I'll bring down this. Again, parallel. I should use my sliding set squares. So again, it's going to be a little bit difficult to do this at home, but this is the way you'll have to practice with these papers. So we may as well get used to it. Okay, and it should end up looking parallel to this. So one side, it looks pretty okay. So I'm just doing that just to help. So there's the line in the middle. Maybe I'm a little bit off center, but again, that's just because of the accuracy of the papers, because of the bend in the fold in this. So that looks to be the main part of the structure done. Okay, I don't think there's anything else that needs to be done. We don't need to have a join in line here. Okay, so hopefully that seems quite okay on the visualizer. So what I want to do now is I want to insert these structures here. So there's obviously a bike stat and these it's here where you can secure on your bike. So they have this line done, and it looks to me, oh yeah, they have this one here because it's gone through that. So what we need to do is we need to bring a parallel line through the bottom and through this corner here. So I think I'll line it up with a line that I already know, and I'll draw using my adjustable or my sliding set square method. Okay, so I need to do the same for here, although oh yes, I see. I was going to say in this case they've made a mistake, but they haven't. It's just a little bit of data that's missing from this elevation. So if I bring this across, try and see which is the right one. That's that one. That's the front edge. Okay, and that's the back edge. So I need a point here. But if you look here, you can see that this height is missing, right? Or this height isn't given on this view because again they're looking straight in. So what I need to do is with my compass, I need to transfer that height. So I'll make it a big enough mark just so that we can see it. So obviously if they put a dot there to show me the height, it would have made my life easier, but they didn't. They wanted me to think about it and say, right, something's missing. Now if I didn't do this, what I'd have is basically sort of a square looking bike rack. But again, the most important thing would be to continue on. So I have that. Now I may as well mark it on every single one when I'm at it, but I think there's going to be a way of me solving this without having to mark it every single one. But I may as well mark it every single one. So what I've done is put a little dot there. That dot, just highlight it in, is basically that corner there. So again, I'll use my slide and set square method. So the most important thing is when I go back to slide and set square method is to use a line that they originally gave me. Don't use a line that you constructed. So I wouldn't use this line, so it'll be enough. I'm going to go back. This was one of the original lines that they gave me. So I'm going to slide it down. I'm sure with my lighter colored pen and bring this forward. So that was that point. So now what I have is the structure that you can attach your bike to. Okay, this sort of structure. But as you can see, there's 1, 2, 3, 4, 5. Okay, I don't know if it's the same as this. It looks the same as this. There's 5 of them. Now I could do that for every single one. And what's easier is just to bring down a number of points, and then you have a few ways. You could either know that they look to be equidistant, so once you got one distance, you could step off the same distance for each one. Possibly the easiest way. There's a few different ways you could do it. It might be the easiest way if the question wasn't so small. Although in some ways it might be an easier way because you have these adjustable set squares that you have to use, or sliding set squares that you have to use, and it's just not that easy to do on the page that you're given. But I'm going to bring them down anyway, and I'm going to mark all the corners. So there's the first one, there's the second one, there's the third one, there's the fourth one, and we have the fifth one. Okay, so I'm now going to bring down the orange dots. So again, I'm lining it up with the line I was originally given, which was this one, I think. And with that one done, could practice to bring the lines. Just can be a little bit difficult to make sure you don't get them mixed up with another one. So they're all along this line. So there's the first one. There's the second one. There's the third one. And there's a lot of lines now on top of each other. And there's the fourth one. So at this stage I would heavy them in. So they should all be parallel. Okay, so I think the first one a little bit off. And then the next thing, there's a few ways you could bring this back down. The alternative would be to actually, you can also, everything will be parallel, so you could actually just slide it along and do it this method. And that happens to be on top of that line. Okay, and there's all the back ones. And again, it's probably the quickest way is to draw that by using the sliding set square method. There's a number of ways you could do it. All are equally acceptable. So I'm going to go back to the first one just to make sure I have the right angle exactly. And there I think I have my structure complete. So I have the bike rack, I have the shelter that's covering it, and I have the bar in the middle. So what it says then, it says the line Y to B represents the straight line path of a football. Show the point of impact with the glass roof in the axonometric view. So basically what they're saying is basically someone kicked a ball from here towards Y, and I don't know whether they're saying that it smashed the roof, but they want to know exactly where did it impact, or which panel maybe they want to know that it impacted. They want to know the exact point. So I can only really see that in this view. So the first thing I want to do, let me see, I'll get a blue, and I'll join B to Y. Okay, so it happens to pretty much crisscross about across that. We can see that that's, while that looks straight in this view, it's actually this way in this view. So it's an angled kick in this view. So they've pointed out B and they've pointed out Y. But they want to know where exactly does it hit the glass. So the only place I can see exactly where it hits the glass is here, in the end view. So I know that if I know it hits the glass there, and if I wanted to bring this down, down parallel, that's the point at which it impacts. And again, we don't know for definite that they don't. I'm assuming they probably want to know on this view. I'm not sure. We're not 100% sure whether they do or don't. So I would always bring it back up regardless, just to make sure. Bring this up here. And how would I find it in that view? Okay, the only way to find it in that view, well, you could possibly do B to Y here. Well, we'll just see what both of them work. B would be along the line. So I think that would be the path of it. Let me see. That would look like it's probably correct, but also that would look like it hits in the second panel, which it does there. Also, if I wanted to check it, or again checking my accuracy, so again, because we're doing this, we might be slightly off. Whatever height it was in this view from the ground, it should be the same height in this view. So it's pretty much perfect. So there's two ways they could have proven it there. And that's the question completed. So the most important thing there is that you wouldn't forget to attempt part B. And also an important thing is sometimes people would have forgot to do the bike structures themselves that came along with it. Okay, so give it a go and see how you get on.